Have you ever really stopped to think about what happens inside your body after a big injury or a major surgery? I mean, it's way more than just stitches and scars. It's this incredibly dramatic, high-stakes biological war for survival, a secret conflict fought by trillions of your cells. We're going to pull back the curtain on this hidden world and get into the real science of recovery.
It's a strange question, right? You've just had a procedure that was meant to fix you, maybe even save your life. But in the days that follow, you just feel awful, weak, totally exhausted. Well, the answer is pretty wild. Your body? It doesn't know the difference between a surgeon's scalpel and a random, brutal accident. To your internal systems, any major injury is a catastrophic attack. And that attack triggers a very ancient, very powerful, and frankly very brutal survival program.
So the very first thing that happens is an alarm goes off. A system-wide code red alert that basically screams, our very existence is under threat. And this isn't just a local thing, it's an immediate, all-hands-on-deck state of emergency.
Now, to really get the chaos of an injury, we first have to appreciate the peace. You see, your body is constantly, tirelessly working to maintain this perfect state of balance. It's called homeostasis. You can think of it as your internal happy place, Everything's running just right. A major physical trauma is the ultimate disruption of this delicate balance.
Here's a way to think about it. That injury is like a massive earthquake that just violently shakes the very foundations of your homeostatic state. Your entire internal environment gets thrown into complete disarray, and that forces the body to shift from its normal day-to-day operations to immediate disaster response.
So how does the alarm actually spread? Well, when your cells get damaged, they burst open and they release these molecules called DAMPs. That stands for Damage-Associated Molecular Patterns. These are essentially 911 calls being sent out from the site of the disaster. And these signals get picked up by your innate immune system, which just instantly awakens and kicks off a massive inflammatory response.
Okay, so the alarm is ringing loud and clear. Now the body shifts from just being on alert to taking action. It enters a full-blown survival mode. And the prime directive is brutally simple. Survive, no matter what it costs. This next phase is all about one thing, generating fuel for the fight.
These alarm signals, they don't stay local. They travel all the way from the injury site, up the spinal cord, and right to the brain's command center, the hypothalamus. The brain gets the message loud and clear. We are under attack. It then kicks off this powerful neuroendocrine stress response. And what does the brain do? It unleashes the generals of its internal army, a cocktail of powerful stress hormones. You've definitely heard of them: cortisol, adrenaline, and glucagon. These so-called counter-regulatory hormones flood your system, and they have one single urgent mission.
And that mission is to get energy, and to get it now. See, at this stage, the body isn't thinking about long-term building projects or regular maintenance. Nope. It is only focused on finding immediate fuel to power the vital organs and that massive immune response. And it will get that fuel from absolutely anywhere it can.
This leads to a process called catabolism, which really shows you the brutal logic of survival. To keep the furnace burning, the body literally starts demolishing parts of its own house. It breaks down its own muscle and fat tissues to convert them into quick, usable energy. This is exactly why patients can lose so much weight and muscle mass after a major trauma.
And this is the crucial point. This whole emergency response is a total double-edged sword. It's designed to save your life in the short term, but if it goes on for too long, the very same mechanisms that are designed to help you can start to cause some pretty serious harm.
And the body's reaction, it's graded. The severity of the injury really matters. A minor surgery might just cause a little bump in your metabolic rate. But major trauma, that triggers an absolutely explosive response. The metabolic rate just skyrockets, and the body starts shedding muscle at an alarming rate. The bigger the earthquake, the more destructive the internal response.
Let's break it down. On one hand, this response is an absolute lifesaver. It gives you immediate fuel, and it puts everything that's non-essential on hold. But, on the other hand, if this catabolism goes on for too long, it leads to severe muscle loss, high blood sugar, and even an impaired immune system, which makes you way more vulnerable to infections and even organ dysfunction.
But here's the thing. This state of emergency can't last forever. If the body is going to truly heal, it has to pivot. There has to be a turning point where the war footing gives way to a brand new phase, reconstruction.
That initial catabolic phase, the breakdown phase, it's really designed to be a short, intense sprint. Once that immediate threat is contained and the patient is stabilized, the body gets the signal that, okay, the crisis is passing. The alarm bells finally start to quiet down.
And that's when we finally enter the anabolic phase. Anabolism is basically the opposite of catabolism. So instead of breaking things down, the body starts building them back up. This is the slow, steady process of repairing damaged tissue and restoring everything that was lost. It's a marathon, not a sprint, and it can go on for weeks. So how does the body make this shift possible? Well, it has its own incredible system of checks and balances. It releases this wave of anti-inflammatory signals. You can think of them as biological peacemakers. Their job is to calm down that initial fiery immune response, basically telling the internal army to stand down so the construction crews can finally get to work.
So with this incredible new understanding of the body's secret war, how has medicine evolved? Well, modern care is a lot less about fighting the body and a lot more about intelligently guiding it through this whole traumatic process. It's really about hacking the stress response.
You see, modern strategies like enhanced recovery after surgery, or ERAS, they're designed with this entire journey in mind. The goals are super clear. Use techniques like minimally invasive surgery to lessen the initial shock, manage pain to control the stress response, support the body to prevent all those harmful complications, and provide the right nutrition to speed up that all-important rebuilding phase.
And that really brings us to the core philosophy of modern trauma care. The best approach isn't to try and suppress this powerful ancient survival response. I mean, that would be totally futile. Instead, the goal is to work with it, to guide it, to manage its excesses, and to support the body's transition from crisis to recovery.
Which leaves us with a pretty fascinating thought, doesn't it? We've learned how to guide the storm. As we get even better at understanding and influencing this incredibly complex biological dance, at truly hacking the stress response, what will recovery from major surgery or trauma even look like in 50 years? Could a major operation one day feel more like a minor inconvenience? The science is pushing us in that very direction.
Okay, here's a wild thought. What if, to save your life after a major operation, your body's first instinct is to destroy itself? It's one of the most brutal and honestly most fascinating paradoxes in all of medicine.
Yeah, I know, it sounds completely backward, doesn't it? But this is the reality of the body's extreme response to the trauma of surgery. So that brings us to the core question of this entire explainer. To heal, why on earth must the body first destroy itself?
All right, let's dive right in. The scientific literature does not pull any punches here. It actually describes the state after a major injury as autocannibalism. Yes, you heard that right. Your body literally starts eating itself. And figuring out why this happens is absolutely essential for surviving and recovering from major surgery.
Now, this isn't some kind of glitch in the system. It's the body's ultimate survival mode. It's like the body declares metabolic martial law, a really desperate but incredibly smart triage system that's designed for one thing and one thing only: survival at all costs.
So here's the bottom line. In a crisis, the body operates on a single ruthless principle: sacrifice the periphery to save the core. It makes a hard choice about what's non-essential, like your muscles, and what is absolutely critical for you to stay alive right now, like your vital organs and your immune system.
So this is how that great reprioritization actually works. First, the trauma of the surgery triggers a massive system-wide alarm. In response, the body starts draining resources. We're talking amino acids from tissues like your muscles. And where does all that good stuff go? It gets rerouted to reinforce the absolute core survival team: your liver, your immune system, and of course, the wound itself. And there's a biological name for this process of controlled self-destruction. It's called catabolism. It's basically the breaking down of complex things, like muscle protein, into simpler building blocks. This unleashes the energy and the materials needed for the most critical repairs. Think of it like this: you're demolishing a less important building just to use its bricks to fortify the castle walls. But as you can imagine, this survival strategy comes at a staggering price. This internal war is paid for by the patient's own body. And let me tell you, the cost can be absolutely catastrophic. So let's look at the real consequences of this battle. Under extreme stress, like a major infection after surgery, the body starts breaking down so much protein that it loses a ton of nitrogen in the urine every day. Now, that nitrogen loss is a direct measure of your muscle being consumed, and it can be the equivalent of breaking down 500 grams of muscle per day. Just to put that into perspective for you, 500 grams is about the weight of 2 big smartphones.
Now imagine losing that much functional tissue from your body every 24 hours. It's just a shocking picture of how aggressive this state of autocannibalism can really get. And this isn't just a number on a page, you know? This massive muscle loss leads directly to this deep, profound weakness and fatigue. It makes it harder to move. It weakens the very muscles you need to breathe, which can lead to chest infections. And it even messes with your gut. All of this just skyrockets the risk of serious complications. And if that wasn't bad enough, get this. The body's stress response also kicks off a severe but temporary insulin resistance. For up to 2 weeks after even a routine surgery, the patient's body acts just like a person with type 2 diabetes, really struggling to use sugar for energy. It just adds another layer of metabolic chaos to the whole situation. So the body is already in a full-blown state of emergency. But for decades, traditional medical care was, without even realizing it, basically throwing gasoline on the fire. We were actually compounding the crisis. I mean, just look at this timeline of traditional care. Patients were starved for 12 hours, sometimes more, before an operation. During surgery, they'd often get cold or a hypothermic. And afterward, they were kept in bed, not moving, sometimes for days. Every single one of these things, starvation, cold, immobility, is its own powerful trigger for the body's stress response. We were just stacking stressor on top of stressor. But this is where the story takes a really fascinating turn. Medicine realized we had to stop fighting the body and start working with it. And this led to a complete revolution in surgical care, a way of essentially hacking the recovery process. The solution is a whole system of evidence-based protocols called ERAS, which stands for Enhanced Recovery After Surgery. It's not one magic bullet. It's a combination of a whole bunch of small, smart changes, all designed to minimize that surgical stress. So here you can see the difference, and it's night and day. The whole philosophy is different. Instead of starving a patient, you carb load them with a special drink before surgery to give their system fuel. Instead of waiting for pain to happen, you block it proactively. And instead of forced bed rest, patients are up and moving as soon as they possibly can. Every piece of ERAS is designed to calm one of those avoidable stressors we were just talking about. And the results? They are absolutely staggering. This chart shows the return to normal function. With the old way, recovery is slow. It's drawn out. With ERAS, patients are back on their feet and back to their lives dramatically faster. It's a total game changer. And the benefits go way beyond just feeling better sooner. ERS protocols have been shown to cut hospital stays by 30 to 50%. That means fewer complications, a faster return to a stable, healthy state, what we call homeostasis, and of course, huge savings in healthcare costs. And this quote just nails the core idea. The power of ERAs isn't in any one thing. It's that multimodal approach. It's the combined synergistic effect of all these small interventions working together to calm the body's stress response instead of making it worse. So, think about how far we've come. We've gone from accidentally making things worse to intelligently partnering with the body's own ancient systems. The success of ERAS is undeniable, but it leaves us with one last, really fascinating question. What's the next frontier in mastering our body's powerful and paradoxical response to injury?